Hey, hi everyone. My name is Kingsley Doko, and I'd like to welcome you again to my YouTube videos, and of course the Juniper series. Um, in the previous videos, we have set up the LADC, if you can remember. And so in this video, and of course subsequent videos, we want to start exploring VPNs as it applies to Juniper devices. Okay, so here we're going to be looking at the virtual private network, specifically the Juniper implementation of IPsec. Okay, this is topology we're going to be messing with. Just like I said, we spent a lot of time, building infrastructure. In LADC, we set up our two XRS devices, which are in cluster mode. So if you missed that part of the video and you want to follow through, then of course you can go back to those videos. But in this section, we want to start exploring VPNs. We want to start looking at the IPsec VPNs. So we're going to talk about VPN. We're going to look at Juniper various implementation. We're going to look at different use cases similar to what we did with the ASA, and we're going to be exhausting all the possible scenarios that could play out, especially for site-to-site and remote access VPN. We're going to be seeing how we can configure them on the CLI, and then maybe later, if we still have some time, we can also look at what are the things we can automate, maybe things with Ansible and all of that stuff. So this is at a very high level. This is topology we'll be messing with. So this is the LA data center. This is our London data center, and this is Amsterdam, and this is New York City. So we have sites spread across the globe, and so our job or our task that we're given is that we should set up VPN connections to these different sites, leveraging IPsec. Okay. But in this first part of the video, we just want to talk about, IPsec in general, overview of IPsec. It's just kind of like a revision class to just look at the overview of IPsec, the various components that make up IPsec, and how we can, take all these components and consume them in building our site-to-site and of course remote access VPN. So Juniper at a very high level supports different flavors of VPN. They support site-to-site. And you also have remote access. Okay, and they also have something called the I think it's called Auto Discovery VPN. It's more like a dynamic VPN where the hub does not really need to statically point to the different sites, but it just allows any IP to come in so long they're able to match the credentials that are set up for the VPN. They also have a flavor called the hub and spoke VPN. I think this is similar to your Cisco dynamic multi-point DMVPN, right? So this is kind of their flavor. But I think we are going to be focusing on the site-to-site, which is the most important part to us. And we're also going to look at the remote access VPN. For the site-to-site, we're going to be using the CLI for all the aspects of the implementation. Remote access VPN, we can also use the CLI, but we'll also see how we can use the GUI for the testing. Okay, so this is the scope of this series on Juniper IPsec. Now, for this very first video, like I said, we're just going to talk about IPsec in general, overview, and we'll try to tie it to, how Juniper implements it for their devices. So I'm just going to move this way so that we have like a whiteboard, and then let's dive deep a bit into IPsec. Now, IPsec is something that it can be sometimes complex, especially because of the different components that actually make up the protocol. It could also be hard to troubleshoot, and it's also it's really not a simple technology, but we are going to like dive in now. Let's look at the pieces that make up the IPsec, and then so that later when we start, doing the implementations, we'll be able to understand it clearly. Now, IPsec itself is just a framework, right? So IPsec is a framework, right? Framework means it has a lot of suite of protocols that make up the IPsec. IPsec itself is not a protocol, but it's a framework, and built into the framework is tons of protocols. Protocols like the encryption algorithms, right? Encryption algorithms, you have hashing algorithms, right? You have authentication methods, right? We have things like encapsulation methods, right? So for under encryption, for example, let's say encryption, at the top is your AES, and then we used to have DES, which I don't know, maybe people still use it now. We also have triple DES, right? And there were some very old protocols that used to exist. It's two sword, or is it blowfish? These are really legacy protocols that you no longer see anywhere today. But you kind of get it. You used to have RC4. I think this is used for server client communication. And then for hashing too, we use MT5 as network engineers a lot for generating crypto keys, RSA keys. You have the SHA-1, you have maybe the SHA-96, 250, I think the SHA-256, 384, 512, right? The authentication, you usually use pre-shared keys, or you can use digital certificates, right? Especially when you have your PKI infrastructure. Encapsulation, you have the ESP, you also have the authentication handler, which is AH. And so many other things that, but at the basic level, I think these are a suite of protocols that make up the IPsec framework. It's just like for developers, they say, okay, this is a Django framework, and you have tons of libraries within that framework, right? So that's the same way IPsec is. So you have suite of protocols that make up the IPsec framework. So we're going to see how we can tie each of these components to build our site-to-site or remote access VPN, and where they all where all these pieces come in to help us build this VPN. Okay, so at a very high level, this IPsec framework has nothing to do with Juniper or Cisco or any vendor. It's just an open standard. So these different vendors come in, they take this framework, and they have their own specific implementation for their devices. Okay, now just like we said Juniper supports site-to-site VPN. Now for site-to-site VPN, which is really the focus of the first part of the video, for site-to-site, we are going to be using, of course, IPsec. Now there's another protocol called the IKEv protocol, which is called the Internet Key Exchange. This is like a transport system for the IPsec. Is what IPsec uses to generate and negotiate, all these IPsec parameters that we mentioned when we talked about the framework of IPsec. So Internet Key Exchange is the mechanism used by IPsec to generate keys, exchange keys, negotiate keys, and things like encryption, authentication, hashing method. The VPN groups, all these things are negotiated between the two net devices or entities. Now, for they to be able to exchange this, that's where Internet Key Exchange comes. So it doesn't just provide a transport mechanism, but it provides what we call a secure. So it's provide a secure way of managing or exchanging these IPsec parameters. Okay, so it provides for identity protection because everything is secure, everything is encrypted, there's authentication, there's so many things that it comes in with, right, for IKE. Now IKE has two flavors. Okay, let me erase this. So IKE has two flavors. We have the version 1, you have the version 2. Okay, now version 1 and version 2 has been there for a very long time. Version 1 has been there for decades, right? I think version 2 came in, was standardized in 2006 in RFC. I forgot the RFC number, but you can always read it up, right? But version 1 has been there for years. So version 2 is the latest, and it's about maybe 1 or 2 decades old as well. But when you go to production environment these days, you see a lot of companies moving from version 1 to version 2. Of course, newer versions are much more efficient, they are faster, they are more secure. In fact, version 2 supports what they call should be cryptography algorithms, things like CBC, things like GCM, Gallows counter mode, cipher blockchaining. So the whole idea of version 2, we're going to talk about version 2 later, but the whole idea of version 2 is it's more secure because it has the ability to use higher grade, encryption algorithms with higher keys. So most of the newer devices we have today support version 2. So you should be able to implement version 2 or migrate from version 1 to version 2. One thing you should know is that version 1 and version 2 are not backward compatible. So what that means is if I have XRSA here and I have XRXB, if I'm running V1 here, I have to run V1 here, right? Also, if I'm running V2, then I have to also run V2 here. You can have V1 here, then negotiating with V2 on the other end. No, they're just not backward compatible. So you have to use one. But situations where you have both V1 and V2, then V2 is definitely going to take precedence and V1 is just going to be there. So you can actually have both running, but if V2 everything matches and the tunnel is up, then the devices are going to use V2 as against the V1. V2 is faster. We'll talk about this, like I said, later. So let's just forget about the comparison between version 1 and version 2 for now. Let's dive deep. Let's understand version 1 first. Let's understand how the mechanism of how he built the tunnel and what are the moving parts of version 1. So I'm just going to erase everything regarding version 2. And let's talk about version 1. Now with version 1, you have 2 tunnels between both devices. You have what we call the phase 1 tunnel. Phase 1 tunnel, then you also have the phase 2 tunnel. Okay, you have the phase 1 tunnel, you also have the phase 2 tunnel. Now phase 1 tunnel is built to enable both devices exchange keys that is going to be used to build the phase 2 tunnels. Yeah, it could be very confusing. I for myself in the beginning, it was always confusing. Now let's look at it this way. So this is my XRXA, this is my XRXB device. Okay, and there's a network, of course, that sits behind this XRS. Okay, so this is server 1 and this is server 2. Now these two applications or these two servers need to talk to each other. This is our public internet, right? So this is our internet. Well, they need to talk to each other. They need to talk to each other securely. Server 1 and server 2 on both sides. Now, if you're implementing IKEv1, what happens is these two devices, you're going to specify your phase 1 parameters, right? Now, the phase 1 parameters include your different algorithms that you want to use to build the phase 1, right? Now, so those parameters that you need to use to build the phase 1 usually referred to as the proposals, right? So if you remember on the Cisco essay, you're going to create, crypto IKEv1 policy, right? And then you need to specify the hashing, the authentication, the VPN group, the lifetime, right? And the encryption. I think they usually call it the Hago process, right? So here you specify the hashing, all right? You specify the authentication, right? You specify the VPN group, which is here is the DH group, right? I think the default now is 14, and then you specify the lifetime of the security association. I think the default is A6400, and then of course encryption. Are you going to be using AES or DES or different keys? So this is the proposals that you create. You can create as many proposals as you want. IKEv1 policy, as Cisco will call it, or Juniper calls it proposals and policies and gateways. So you can create as many. I think Juniper supports up to 4, but Cisco, I think, I don't know. You can create as many as you want. Now let's come back. Let's not miss our discussion. So all these are created or specified when you are trying to build the phase 1 tunnel. So XRI is going to take this proposal and send it across using IKE to the other device, right? And then the other device look at this proposal, compare it with what it is configured on its own end. It's either going to accept it or it's going to reject it, right? Devices will send multiple proposals. It doesn't have to be one, right? But the whole idea is in one of those many proposals that you have, there has to be a match between both sides, where the human group, the AES, the authentication, everything has to match from both sides. Now, once there's a match, that is when they set up that tunnel we refer to as the phase 1 tunnel, right? Now, the phase 1 tunnel is set up, right? Once the phase 1 tunnel is established, the device needs to move on to the phase 2 tunnel. So let's say this is the phase 2 tunnel, right? So this is the second tunnel. Now, what is the difference between phase 1 and phase 2 tunnels? Which is really what we are trying to explain here. Phase 1 tunnel is not used for encryption of the actual payload or application, right? Remember, the whole idea why we're setting up this side-to-side VPN is to allow these two servers to talk to each other, correct? Now, the traffic that goes between server 1 and server 2 never goes through this phase 1 tunnel. Rather, phase 1 tunnel is only set up to allow these devices set up phase 2 tunnel. Phase 2 tunnel is where the actual payload is encrypted, or where the actual data that goes between both servers go through. Phase 1 is only set up to allow those devices to exchange the IPsec parameters required to create the phase 2 tunnel. Okay, so once they go through this proposal, they say, okay, authentication, I want to use pre-shared key or certificate. I think if we have time, we're going to look at certificate implementation and pre-shared. For now, we use pre-shared keys. So once the phase 1 is set up, then they go ahead and move on to phase 2. And in phase 2, that is where you start looking at things like the IPsec policy, right? The IPsec policies, right? Something Cisco you should be familiar with, things like the transform sets, right? With the transform set, that's where you specify the encapsulation that you want to use, the authentication algorithm, the hashing algorithm, the encryption algorithm, the PFS, especially if you want to rekey at phase 2. All those parameters are negotiated over the phase 1 tunnel, because phase 1 tunnel is already set up, is secure, right? And so any traffic that goes through that phase 1 tunnel is already kind of encrypted. So they are exchanging IPsec parameters, but in a secure way. That's the whole idea of phase 1. But in phase 2, this is where the actual payload. So once phase 2 is also established, that is when. So traffic between these two devices will actually go through the phase 2 tunnel, not the phase 1. Phase 1 will always be there and up, right? While phase 2 will be used for encrypting the actual payload or the application that goes through between both devices. Okay, so that's really the difference between phase 1 and phase 2. Okay, so going forward, we said that, okay, in phase 1, yes, you have to specify your policies or your proposals that goes on between both devices. Then in phase 2, there's also the proposals that goes on, right? But we only said that this now happens in a secure way because everything is being piped through the phase 1 tunnel that was already set up. Okay. Now we're going to come back to phase 2 and talk about it a little bit, but let's look at what really happened in phase 1. Okay, let's look at what really happened in phase 1, and then when we're done with that, we can come back to phase 2. So I'm just going to grab my eraser now. Let me see if I can erase all of this. So for phase 1 operates in 2 modes. Okay, so phase 1 operates in 2 modes. There's what we call the main mode. There's something we also call the aggressive mode. Okay, for the main mode, 6 messages are exchanged. 6 messages. We're going to look at the messages that are sent. Then the aggressive mode, there are only 3 messages. Right? Now, the default is the main mode. If you don't specify, default is main mode. With main mode, one of the advantages main mode has over the aggressive mode is that main mode provides for identity protection. We're going to look at the messages. We'll look at it now, but in the future, when we actually set up this site-to-site tunnel, we're going to do a capture of the negotiation that goes on between the devices. We are going to see how this main mode actually operates. What are the different type of messages that flow between when both devices are negotiating these IPsec parameters in the main mode, right? Main mode has more messages that are being sent across, but it provides for identity protection. Aggressive mode is faster because it uses less messages, but there's no identity protection. Now let's look at it. What is main mode? Now usually when you troubleshoot site-to-site VPN issues with ASA, you might have come across terms like when you say show crypto IKev1 security associations and all, it might tell you, oh, I'm stuck in one of these stages of information exchange in the main mode. So for main mode, 6 messages are exchanged. What are the messages? So let me just put it this way. MM1, you have your MM2, right? So this is between the 2 devices now. So let's say this is SROX A and this is XROX B. There's MM3, there's MM4, which is like a main mode message for something like that. There is MM5, there's MM6. Okay, now for MM1, this is sent by the initiator, or really the first device that you configured. Or if you're trying to set up VPN between your company and the other company, and you were the first to set it up, something like that, then you are going to be the initiator. So we're going to send some information to the secondary. What are the information? I'm going to include my encryption algorithm plus the authentication algorithm that I'm using. Okay, so authentication is, I use the password or certificate, right? He is also going to send down his own message. So that was what makes up the MM1. The MM2 is also going to be the same message, but this time from the remote side. So it's also going to be the encryption plus authentication. Now there are other parameters that are sent, but the most important ones that are really very important, right? Because maybe things like the vendor ID, we are really not really interested in that for now. There's no IOCs, there's HDROs, so maybe there's some other packets that actually be sent, but at a very high level, these are the 2 informations that we're interested in: encryption and authentication protocol that we are using, all right, and the values. So MM2, he's going to respond. You see, here's my encryption and authentication algorithm. So at MM2, it means both devices now understand that they want to encrypt with AES, or we want to encrypt with SHA-1 or SHA-256 or 384, that kind of stuff. MM3 is when they send DH group, right? For example, I would say I'm using group 14, right? He's also going to respond with I'm using group 14. Or if he's using something different, he's going to say this is what I have. Remember, they all have multiple proposals, so it's great. It's okay. I accept what you're sending to me, right? So that is MM4. MM5 is where identity verification narrowly comes in. Now, what you should know is that from MM1 to this MM3 or MM2 to MM4, every packet that is exchanged at this level is not encrypted, is unencrypted, and even the peers are not authenticated, and there's no authentication. Okay, so at this stage it is really vulnerable because everything is in plain text. So if we do a packet capture, we should be able to see these messages. But from MM5 to 6, this is where you have what we call identity verification, right? It's going to say, oh, this is me, and this is my IP, or this is my FQDN, right? And he too is going to send his, his identity information. So there's also verification here, right? So there's going to check their password and so many other things to be sure they are who they say they are. Now, this identity exchange or verification is no longer done in plain text because they've already know about what encryption and authentication algorithms they are going to be using, and they have already exchanged the VPN group, which help them to derive keys for encryption, right? The VPN group is what they use to, it's just kind of code. You don't really know how to know, at least at this level, we don't know to know how, except you're trying to create a different VPN protocol. But what we know is that this VPN group, once the values match, there's a way they run these algorithms within themselves, and they both create these keys that they use for encryption. So it means at once the VPN groups are exchanged, they are not able to what? Encrypt. And they know the protocol they are supposed to use to encrypt. In this case, we said maybe it's AES, right? So once that is established, the identity verification is now done securely encrypted. So here, there's now encryption. So if there was somebody in the middle, there's a man in the middle attack, or somebody is trying to sniff on the conversation, he's going to get lost after MM4 has been sent, because whatever has been behind the scene is now being encrypted. That's how that applies to the main modes. So if you look at it, these are the 6 messages: MM1, MM2, MM3, MM4, MM5, and the MM6. Right? That applies to the main mode. So that's why we say that from the main mode, there is identity protection. Now for the aggressive mode, let me try to erase this. I don't want to click everything. So aggressive mode is also similar to the main mode. The only difference is it bundles the whole messages instead of sending them individually, right? For example, so for the aggressive mode, you still have your AM. So let's call it AM to signify aggressive. There's AM1, there's also AM2, and there's AM3. It's just 3 messages. So here, and then one comes this direction, and also this direction. So here you're just going to say, okay, my encryption plus my authentication, right? Plus my the VPN group plus my ID or your proxy ID, which is your identification. Everything is modeled together and sent across to the peer device, right? So the peer device too is going to send its own, say this is my encryption plus authentication plus DH plus my ID. Is going to grab all of these plus the acknowledgement, to say, okay, I accept your proposal. You kind of get it. So it's going to also add the acknowledgement to say, oh, I can confirm that, oh, I have a proposal that matches what you sent to me. Everything is going to send to the other peer device. And then he too would send his kind of confirmation or what you call the acknowledgement, right? So these are just the 3 messages that are sent in aggressive mode. Now, what is the problem with this? Remember, I see the ID is exchanged in plain text, right? Because everything is sent all at once. There's nothing hidden. So whoever, if there's a guy, if there's a hacker in the middle, and there's looking at or snipping at this traffic, he might be able to take all this information and do some kind of attack or build tunnels to the device. So that's why there's no identity protection for the aggressive mode. So it's faster because it's using less messages, but there's no security for the identities of the devices. So that is really the phase 1 protocol. So once there's a match on both sides, then the phase 1 is established. So once the tunnel is established, then they move over to phase 2. So let's go over to phase 2 now. Now for the phase 2, that is where we build the security association, right? Which is actually what is used to build the tunnel between both devices. Okay, so in phase 2, this is phase 2, right? 3 messages are also exchanged. So you have 3 messages. So what that means is, if I'm running in main mode and I'm also running, of course you always have to run phase 2, I will have to exchange up to 9 messages, right? So in phase 2, 3 messages are exchanged. Phase 2 typically operates in what we call the quick mode. Quick mode. You can call it QM. So so you have QM1, you have your QM2, then you have your QM3. Okay. So in phase 2, if you're familiar with Cisco, you remember that's where you configure things like the transform set, right? Transform set. Right? In Juniper, that's where we create something called the IPsec proposal, and you tie it to the IPsec policy. Okay? And then you start bringing in the gateways, just start tying all these components together, right? So it therefore means in quick mode, he is going to send his security association parameters, right? Which in this case, like, since we are used, so which in this case will include your proposal, your IPsec proposal, right? And which definitely translate to the policies and all. But I like to use it. Let's since we understand Cisco more, let's put it this way. So for Cisco, this is going to be like the transform set, right? And within your transform set, what are the things you set? You set your encryption algorithm, which is the same for Juniper though, right? The authentication algorithm, right? The ESP, the encapsulation headers protocol that you want to use, right? And you also talk about hashing, right? So all this makes up the security associations, security attribute or policies, how you want to call it, that is sent across to the other end. It also includes things like the traffic selector, right? The traffic selector, right? So by traffic selector, ASA uses access list to match the trusting traffic. Juniper uses policies, especially for policy-based VPN. It also uses route, where you can just tunnel. You tunnel the remote prefix. So to get to this remote site, I want to send it to ST secure tunnel 0. That kind of thing. We'll talk about that. So all this make up the informations that are sent across. You could also include maybe some NAT related informations, right? Your NAT, informations that could be sent across, right? So it bundles all these informations, right, as part of the SA and send it to QM2. Q2 does not need to send its own back to the device on the other side does not necessarily need to exchange its own attributes, IPsec attributes or parameters with the device, with his peer. So what it does is, this device gets it, right? Then he said, okay, it's going to compare to what it has, what is configured on its own end. If there's a match, it's just going to reply with kind of yes or no, like confirmed. We can go ahead and build our IPsec tunnel with this. That's the QM2 message. And similarly, the QM3 message is just saying, it's just kind of like an acknowledgement, right? So that is really the 3 messages that are sent across for the phase 2. So once there's a merge and they both acknowledge each other, confirm that their parameters are okay, then phase 2 comes up. So once phase 2 comes up, then the actual traffic between both servers or both network now flow through the phase 2 tunnel. I think that's pretty much at the basic level what you need to know about the IKev1. Okay, now it's time to move over to, so for IKev2, like we said before, IKev2 is the latest IKE version that exists, and is what is mostly used in most production environment today. So for IKev2 is also behaves similarly to IKev1. Or IKev2, like we said, so we said for IKev1, we said phase 1 uses, so let's say for example, so IKev1, let's say for example, phase 1 is using main mode, right? So that means 6 messages, right? Then this is phase 1. Then for phase 2, right? Phase 2 of course uses the quick mode, which is the default, and it's mandatory 3 messages. So altogether that makes 9 messages for you to build the tunnel. For IKev2 at the basic level, it's 4 messages. When we set it up, we're going to try to grab the packets to see these messages, right? At the basic, but at the same time, you can go as far as 10 to 20 to 30 messages that are exchanged. So it depends on the number of tunnel, the number of security associations, the complexity of the VPN that you are setting up. But at the minimum, it's 4 messages. Same applies to IKev1 though. It's 9 messages, but it depends on the implementation. You can have more security associations. So it depends on how really complex it is. We're going to talk about these messages, but what are really the advantage of IKev1, IKev2 over IKev1? We tried to talk about it in the beginning, that its ability to support higher encryption algorithms, right? So we talked about the suite B cryptography, which is something from the US government, right? Higher end encryption, right? I think the US government has a way of classifying their data or information, like top secret information, should be able to use these high-end encryption algorithms to keep the data secure. All right. So IKev2 supports this. It's faster because it uses less messages. It uses fewer messages, so that makes it faster. It has some additional attributes. Things like the sequence numbers. It uses things like sequence numbers, acknowledgement, like TCP, similar to the way TCP behaves. It also has error correction capabilities, right? There's always the way communication occurs in IKev2. There's always the initiator who is making the request, right? And then there's also the responder, right, who is replying the messages. Okay, so it's kind of just similar to the way TCP behaves. There's reliability in the communication. There's retransmission that can happen. There's error corrections. It uses sequence numbers. So that makes it more secure. It's less susceptible to, reverse engineering or cracking of those codes, or things like the increases security for DDoS related kind of thing. So IKev2 is really way better than the IKev1. It's a better implementation. It's more efficient, and so that's why most organizations are moving from IKev1 to IKev2. But we don't really want to. IKev2 can be really complex when you're trying to really understand how the protocol and the algorithms and everything works. But what we should just talk about now is that For IKev2, there's really no, the whole idea of phase 1. So the whole idea of phase 1 and phase 2 does not exist with IKev2. It's not like it doesn't exist, but that line, there's a lot of overlaps, right? So there's a lot of overlaps, and so you can't really say, oh, this is my IKev1, this is phase 1, this is phase 2. No. Yes, there's the parent tunnel that is actually set up, and then you can have child security association. So instead of calling it phase 1, you can call it maybe something like the parent tunnel, right? This is just my own way of describing, but of course there's always the child security association, right? This child security association applies to the different traffic selectors, right? The different type of traffic that goes between the tunnels, right? Maybe between two subnets in both remote sites. Maybe both sides might have different type of subnet, and this subnet, there's a way we use traffic selectors to segment them such that the traffic are different. So what the ASA or what the devices end up having are child security associations, but they are derived from the parent tunnel. In this case, the parent tunnel can be likened to not even phase 1 or phase 2, but the way IKev2 operates is quite different from IKev1. There's no concept of phase 1 or phase 2. Now, the messages that are sent during the negotiation is just 4 messages, like we said, right? So if this is X arrow X A, this is X arrow X B. Now, when we build the tunnel for IKev2 and we do our packet capture, we'll probably understand it better on the type of information that flows between both devices. And what would you call phase 1 and what would you call phase 2? Now, let me try to explain the messages that flows between both devices when IKev2 is enabled. Now, so there's always going to be the initiator, which is something we said. So there's always going to be the initiator, and there's also going to be the responder, right? Now, the initiator is going to send what we call the Ethernet Key Exchange security association in its initialization, something like that. And then the responder is also going to respond with the same IKE security association in its package or message. Now, what does this IKexa init, what are the components? Now, there are a lot of moving parts to it, but at the basic level, what you have is also similar to what you have for IKev1. So here you have your MM1 message. Remember, MM1 is authentication encryption, and then you also have your MM3 message. Okay, so it takes the authentication, it takes the encryption, it takes the VPN group. There are also other parameters like which are not really the vendor ID, the nuance, right? The NAT related information. There's also something called the HDROs. So there are other components that we are not even talking about here that is sent across, right? But all these is what makes up these messages, this message that is sent across, right? Same for the response. So he's going to respond with MM2 and MM4. Okay, in addition to this additional information that are sent across to both sides. Then he is now going to respond back with, remember, at this level there's no authentication and there's also no encryption. But once they've successfully established that, once they've gotten the VPN group they are using and they have exchanged the encryption and authentication algorithms, then they can now move on to what we call, they will now request for something called the IKE authentication request. I think that's what it's called, right? Now the IKE authentication request is similar to your MM5 in phase 1. right? So he's also going to respond with mm6. So it's also going to be ike auth response in this case. Okay, so this is similar to the mm6. It's not just mm5, it's going to be mm5 plus qm1. Remember, qm1 is quick mode 1 message that is sent, which include those security association information in phase 1, right? So it's also going to be mm6 plus your quick mode m1. If you remember, if you're following the video, when we said that qm1 is where they actually send their IPsec parameters or IPsec proposals. So all those are the 4 messages that are sent in ikev2. ikev2 is so that's why you see we cannot just say now when they exchange this information and there is a match, that is when this parent tunnel is created, right? So the tunnel is established. But you can also go ahead to start having things like the child security associations, which is really related to the traffic selectors or different type of traffic that will go through, or the different type of subnet that we talk that will be communicating with each other over the ikev2 tunnel. Now we'll understand the ikev2 clearer later when we set it up and we start looking at the individual packets, right? And we see how this negotiation goes on. But there's really no clear line between phase 1 and phase 2 in ikev2. If you want to read more, know more about ikev2, I suggest you just read the RFC for ikev2. It's explained better there, and you have a better understanding. But we are not really interested in, yes, you need to know how these messages work, because when the tunnel is broken, you need to know how to, fix it. You need to know where it's broken, why it's broken, So that's why it's really important we understand these different messages that are sent across the devices. Now, that is really, we don't want to go too far more than this. This is really the overview of IPsec in general. But now we will have to begin. Let's talk about how Juniper implements. Now for Juniper, there's really no difference between how Juniper implements site-to-site VPN, different from what Cisco does. But for Juniper, there's always the concept of policy-based VPN and route-based VPN. Now, the difference between the policy-based VPN and route-based VPN is just how do you match what to go through the tunnel. That's selectors, traffic selector, right? Selectors. For policy-based VPN means you are using policy you are using security policies, right? So you are using security policies to define what is sent through the tunnel. You are going to see the configuration where you say, oh, if it's coming from this source and it's going to this destination, then I want to tunnel it through this VPN tunnel, right? So here we are using security policies, but for route-based VPN, we are using routing, right? So the tunnel is always going to be maybe ST0. You're going to say, okay, IP routes to 2.2.2.2/32, something like this. I want to forward it through this tunnel. This is the recommended implementation for Juniper. Juniper says, as much as possible, use the route-based VPN. Policy-based VPN is really used for basic VPNs. But when you start talking about complexity, which is really what we're going to be looking at in this implementation, where you start having things like overlapping nav, when you need to help in, when you need to send certain traffic through certain tunnel, and the other tunnel need to go through the internet, there's a limit to what you can do with policy-based VPN. And one of the very big disadvantages of policy-based VPN is that if I have, let's say this is X arrow X A and this is X arrow X B, right? So if I have two subnets here, 2.2.2.2/30, let's say 32, and let's say I have 1.1.1.1/32, for these two devices to communicate, you are going to have two security association, right? So there's a security association for the outgoing, the security association for the incoming, right? Now, if I have 4.4.4/32 that needs to talk to 5.5.5/32, I will need to set up another different security association. So it means just for two IPs or for two servers on both sides to talk to each other, we're already looking at what? So here is 2, here is 2, right? Here is 2 tunnels, here is going to be 2 tunnels. So that makes it resource intensive. We're going to see all of this when we implement. So a policy-based VPN can really take a lot of throughput from a lot of resources from the device. That is why Juniper recommends that as much as possible, as far as you can, you should use the router-based VPN. We'll dive deep into each of these implementation from the next video. Maybe the next video we'll talk about what are the steps to set up site-to-site VPN. It's really very simple. You create your proposals, you create your policies for phase 1, you create your gateways, you tie them to interfaces, you start to specify your identities, you know. It's same for IPsec policy, which is the phase 2. Let's talk about the proposals, the policies, the PFS values. We'll talk about this in the next video. So in the next video, we are going to start looking at the configuration step, and then we also start the configuration of the site-to-site VPN. Okay, so if you enjoyed this video, please subscribe, and I see you in the next video, in which we will start configuring IPsec site-to-site for the Juniper devices. So in the first videos, we're going to set up, site-to-site between this device using policy as our selectors, policy-based VPN. We also do for this, and then we also do for the ASA, right? Once that is achieved, then we look at what is possible, what else can we do? Like, for example, can this device talk to this device using policy-based VPN? And then can you do overlapping subnet? Is it possible? Can you have overlapping subnet? Can you do help pinning? We're just trying to explore how far we can go with the policy-based VPN. Then when we are done with that, then we can move on to this Juniper recommended way of implementing VPN, which is the route-based VPN. All right, thank you so much, and see you in the next video. Bye.